acid. Definitions of acid. An acid is typically defined as a substance that releases hydrogen ion in aqueous solution. Depending on the theory used, acid can be understood slightly differently. Arrhenius' definition talks about acid being dissolved when dissolved in aqueous solution to release hydrogen ion. This kind of acid are substances that increase the concentration of hydrogen ions in aqueous solution. For example, hydrochloric acid releases hydrogen ion when dissociated in aqueous solution, same as sulfuric acid, nitric acid. Another definition is Brustolori definition, which is more general and applies to reactions beyond just water-based solution, where acid is being seen as a proton donor. So acid are proton donors in which they donate proton, and there is another proton acceptor which happen to be base. Example is ammonium ion. Ammonium ion in water will release hydronium ion H3O+. And there are some other examples of Brustolori acids. Third definition is Lewis. Lewis definition seeing acids as electron pair acceptor, in which electron pair is being accepted by acid while the Lewis base donated the electron pair. Example of Lewis acid is boron trifluoride, BF3, which accepts electron pair from ammonia, forming a coordinate covalent bond. Then there are types of acid which are classified in several ways depending on their strength, origin, or their chemical structure. There is strong versus weak acid, where the strong acid are substances that have completely dissociated in aqueous solution. Example is also the hydrochloric acid, sulfuric acid, nitric acid. The weak acid partially dissociates in aqueous solution, leaving many molecules intact. For example, formic acid, acetic acid, citric acid. Organic versus inorganic acid is also another type of acid. Organic acid contains carbon and are typically found in biological systems. Organic acid undergoes slow reaction compared to the inorganic. So these organic acid examples are citric acid, acetic acid, and so on. Inorganic acid, which are also called mineral acids, do not contain carbon, and these are sulfuric acid, the perchloric acid, hydrochloric acid, nitric acid, as the case may be. Acid can also be categorized as monoprotic, diprotic, polyprotic acids, where monoprotic acid are acids that donate one proton per molecule. Acid in this case have replaceable hydrogen. So in the case of the protic acid, these are acids that donate 2 protons. That's in the case of H2SO4. Polyprotic can donate more than 2 protons. For example, phosphoric acid H3PO4. How are acids prepared? Acids are prepared from non-metal oxide, which are also called acid anhydride. These acids are formed by the reaction of non-metal oxides with water. In the case of sulfur dioxide reacting with water to give sulfurous acid, carbon dioxide reacting with water to form carbonic acid. There is also direct combination from elements, that's direct synthesis of elements. Certain acids are synthesized in this manner, where the constituent elements are combined directly. In the case of hydrogen gas reacting with chlorine gas to give hydrogen chloride, HCl. We also can form acid by, in the case, can also be produced by the reaction of strong acid and weak base. Ammonium chloride can be made by reacting ammonia and with hydrochloric acid. Some acids are made by the reaction of sulfuric acid with their salt. In the case of H2SO4 reacting with sodium chloride, potassium chloride, even the same with the nitrate to form nitric acid. What are the properties of acid? Acid have salt taste. They conduct electricity in aqueous solution by releasing ions. Acid have pH less than 7. Strong acid have lower pH, close to 0, while the weak ones have pH close to 7. What are the reactivity or chemical properties? 1, they react with metals to form hydrogen gas. In the case of zinc, reacting with hydrochloric acid to release hydrogen gas to the atmosphere. They also undergo neutralization reaction. There's the reaction of acid and base to form salt and water only. HCl is also an example with sodium hydroxide to form sodium chloride and H2O. Same with sulfuric acid with sodium hydroxide to form sulfate and water. The nitric acid similarly reacts with sodium hydroxide, the base, the alkali, to form nitrate and water. They also react with carbonate to release carbon dioxide gas and also form water and salt. And in the case of acetic acid, reacting with sodium carbonate to form sodium acetate, carbon dioxide and water. The uses of acid are for industrial purpose, in manufacture of fertilizer, detergent. In the case of sulfuric acid, used in manufacturing fertilizer, detergent and petroleum refining. Nitric acid being used as fertilizer, also hydrochloric acid for cleaning metals and producing chlorides, and in some household cleaning products, those ones that are used in toilet and some other things. They are also for biological uses, like citric acid found in citrus plays a role in Krebs cycle. Amino acids, which are also the building blocks of protein, are essential for life. In everyday use, vinegar contains acetic acid and is used in cooking and as cleaning agent. And in case of sulfuric acid, used in lead acid battery.